Everybody, in this video, I want to continue working with equations and start getting us geared up for more problem solving and word problems. So let's do some examples here of converting numerical sentences into equations. So again, words in English into mathematics. And we're just going to do a couple basic ones to start. So now, if you need to review those keywords, we've said them a few times in the videos now, so you can go back to an earlier video and again, review those keywords for different terms here as we go through. So I think it's easier just to see some examples. So our first example is the product of 3 and 5 is 15. So I'm not even bringing in variables here yet. I'm just practicing writing. Remember, product means multiplication there. So we're multiplying 3 and 5. And is a keyword for equality. So that's one of those keywords we're going to look for to represent an equation now. So this says 3 times 5 equals 15. And of course, if you don't like the raised dot symbol, you can always use parentheses as well. I do encourage you not to use the X symbol for multiplication at this point because we're bringing in variables now. So I would use either the raised dot or use parentheses instead to represent multiplication. So here we have twice. So twice means times 2. And sum is addition. So notice that we're doing twice the sum. So this is one of those parenthesis examples. So we're doing 2 times the sum of 3 and 4. So 3 plus 4. Yields is another keyword for equality. So equals 14. You don't need that there. And one more of this style. So quotient represents division. So the quotient of negative 36 and 9 is equal to, obviously represents equality there as well, negative 4. So we can write this as negative 36 divided by 9 equals negative 4, or negative 36 divided by 9 equals negative 4. So both of those are correct ways to represent the quotient. So keywords for equation that we've seen so far are is, obviously the word equal, yields, and there are others too. So some others could be same, like so same as or is the same as well. Sometimes that word total, I'm gonna put total in parentheses because total does represent addition, but the answer is the total of items. So if you're going shopping, let's say, and your total price was $100, then that represents that all the items added together equals 100. So sometimes that word total as well can help to show you what your value is equal to. And again, those are just a couple to be on the lookout for so far. And then one more I'm going to add as well, I'm going to sneak it in here, would be amounts to is another one that we see quite a bit as well. All right, so let's do some more examples and actually bring in variables this time. So we're going to write each sentence as an equation, and we can use x to represent a number. So 6 increased by a number is 5. So again, if you need to go back to that list of keywords that we've set up a few times, go ahead and do that. Increase is one of those words that typically means to add. So 6 increased by, and then again, we're letting x be our number here. Is means equals 5. Now we could also take this to the next step as well. So once you have your equation set up, now we can go ahead and solve it, right? So in this case, we would subtract 6 from both sides. And we have positive x is equal to -1. So we can get our answer here after we have our equation, depending on what the question is asking for. So here, twice a number equals -20. So twice we know means times 2, and we're letting the number be x. So here, that word twice is referring right to the x. So this is 2x equals -20. Now notice I'm just going right through these examples. So for more simple word problems like this, translation word problems, we're just going really left to right and kind of reading through looking for those keywords. And again, if this is something that we need to solve, here I want the x by itself, and there's not really anything to simplify. So I'm just going to divide both sides by 2, and I can get my answer here of x equals -10. All right, let's do some more examples. So a number subtracted with 10 yields 35. Again, we're letting the number be x. Subtracted is obviously subtracted. Now this word is with, it doesn't say from. So subtracted with is just the word with. So we're just doing a regular subtraction problem. And that word yields does mean equals. So a number subtracted with 10 yields 35. Here again, not too much to simplify. So what we're doing is just adding 10 to both sides there to get x by itself. We could have our solution of 45. Here, 3 times the sum. So 3 times obviously means 3 times. But notice here we're multiplying by the sum. So this is going to be 3 times the sum of a number and 5. So x plus 5 is equals -30. Now, if we want to solve this one, I'm just going to solve it right here this time. I'm just going to distribute that 3 throughout. So I'd have 3x plus 15 equals -30. Now, there isn't anything to simplify on each side, but I do need to get the x by itself. So since my x's are already on the left, I'm going to bring my numbers to the right. So this plus 15 becomes a -15. And then now that all my like terms are combined, I can go ahead and divide on both sides by 3 and get the answer of -15 here. The quotient of twice a number and 3, running out of room here, is equal to 1. So quotient, remember, means division. And we have twice a number, so that's going to be 2x. So we're looking at the quotient of 2x and 3 is equal to 1. Now this one's a little bit different to solve. I kind of like this one. So here I have both multiplication and division in the same problem. So you could do it a few different ways. One way that I like to do it is to kind of do it in 2 steps. So I'll show you that way. And then I'll show you another way you can also do it. So here, if I have a fraction problem, I tend to like to get rid of the fraction part first. So the opposite of dividing by 3 is multiplying by 3. So what I can do is multiply by 3 on both sides. And then that gives me 2x equals 1 times 3 is 3. And now I can divide both sides by 2. Now I know we really haven't done much work with fractions yet. We will, but we can just leave this as x equals 3/2, for instance. Over here, and again, we're going to do more of this with fractions. So this is kind of like an introduction to once we get to fractions next week, or next couple of videos, I should say. Think about how you can cancel 2/3. So if you remember any of your fraction skills from before, the opposite of 2/3 is 3/2. We could flip it. So another way that you can deal with something like this is to flip the whole thing. What happens is it cancels the 3's and it cancels the 2 at once. And then what you do is you just multiply this straight across. So remember, with your fractions, we can always put a whole number over 1, and then 1 times 3 is 3, and 1 times 2 is 2. So just kind of a little precursor to where we're going with those fraction problems very soon as well. Alrighty, let's do maybe one more example. Okay, so we're going to, again, translate and then solve. So twice a number plus 3 is the same as the number minus 6. So twice a number, that means 2 times, and the number we're using is just x. Plus means addition, is the same as, is equal. So again, that word same or is also forms equals. So far on the left side, I have 2x plus 3 equals, and then I have the number minus 6. So x minus 6. So I translate first, and then now I can go ahead and solve. So I'm just going to put my divider in here. Notice that I have x's on both sides and I have numbers on both sides, so I'm going to choose which way I want to go. Again, I'm going to bring my x's left. That tends to be a favorite of most students. And if there's no number, there is a 1 there. So a positive 1 changes to a minus 1 or a negative 1. When I move it to the other side, 2 minus 1 is just 1. So I have 1x plus 3 equals negative 6. Now I'm going to bring my 3 to the other side. So plus becomes a minus or a negative. And also 1 times x is just x. So I can write this as x. And negative 6 plus negative 3 is negative 9. So here I have my final answer as well. Now you can still check your answers by plugging into the equation, but you may also want to plug it into the wording, because remember we created the equation ourselves here. So to help check that you didn't make a mistake there, you may want to plug it into the wording. So twice a number would be 2 times negative 9, which is negative 18, plus 3. So that's what I have over here. So I'm getting what? Negative 15 is the same as the number minus 6. So negative 9 plus negative 6 is also negative 15. So it does seem to check out as well in the wording as well as if you try the equation separately.